Well, I've been studying the temperature of my Kama sitting out in the sun. I have a couple thermocouples hooked up. We're feeding into a data logger. I'm measuring ambient air temperature inside the car. I'm measuring temperature at the windshield, doing the inlet and doing the exhaust from the Kama's fan unit. So sitting out here in the sun, it's not too warm today. It's about 75. We're sitting at about 56 degrees in the windshield, about 5 degrees cooler in the Kama. So I'm going to go ahead and start up the car. And we're sitting at about 65. We'll turn it to 72. So right now the Kama is 3 degrees. So after looking at the data from the temperature logger, there was nothing really too startling with the Kama. We've all kind of known that the temperature at the windshield is considerably warmer than the temperature out here where the user would be. The Kama basically draws in air from the windshield and exits out the side. Looking at the temperature inlet versus outlet, there's a good 10 degrees difference in that temperature, and then the outlet temperature is always about 10 degrees below the internal temperature of the Kama. That's in centigrade. As part of the mitigation effort, I realized that I need to pull in cooler air to cool the Kama down. So what I've done is created this little air scoop that plugs into the back of the Kama. Doesn't require opening it up. It just pushes in and stays in place. I've also added some baffling on the inside to cut down on any reflected sounds. So, you try to get a couple benefits out of one device. So we're going to install this and see how it looks. Okay, just pushes down there, and it basically allows the air to come in from the cooler boundary layer underneath the Kama rather than pulling it in from the windshield zone. So one of the questions you may have regarding this little cool air scoop is, doesn't it restrict flow of the air into the Kama? Well, first, the fan inside of here is not as large as these vents are. It's about 5 millimeters smaller all the way around. So we're really not reflecting air into this. Secondly, if you look at the cross-sectional area of the fan inlet, it's only around 850 millimeters squared. If you calculate the air exhaust, we're close to 1200 millimeters squared. And if we look at the heat sink on the inside of this thing, it's about 1400 millimeters square of space. So if anything, you would do a little better to open this up. But this little bit of space here on the edge, since it's outside the fan's diameter, doesn't restrict airflow. The second thing that I did to try to mitigate heat in the Kama was to create a little reflector. What I've done is I've taken a thermally stable plastic and added reflective aluminum tape onto it. Looking at the bottom of it, I created air gaps underneath of it so that the thing doesn't actually sit down, but it allows air to move in and around. And then we have little side tabs and also on the back that keep it from coming off. I've added some cutouts, one right here and one for the button if you want to access that button, but for the purpose of this, I've just left this one intact, but I've pushed the little cord button out. My goal was to have it hang over about 1/2 inch just to provide shade when the sun's overhead. So we have the air scoop pulling in cool air from below. We have the heat shield. The third thing that I did to try to improve the Kama's performance during hotter days is to create a larger mount. I kept the design the same for the two inlets. I did make it a lot bigger, and we added some cool lettering to it. But anyway, this is a thermally stable PETG filament. It's clear, the VHB is gray. So when this goes on, it essentially goes on the same as the other mount. The next video I'll show kind of how we put it on. We added straight lines to the bottom and the top to allow the use of a straight edge. I've fixed a straight edge on either side with just some blue painter's tape, and I've aligned that straight edge so it gives me a balanced perspective. Just pull up to a garage door or something with a horizontal line, and that will kind of assist you in leveling. Wanted to show how to get the mount off. I use a little IPA. I'll spray it behind the mount and use a scraper. Make sure you put a towel down to prevent any liquid from getting on your dashboard. And so I'll spray it. Okay. And then get behind. So this is my technique for installing. I tape a ruler across the windshield. I just make sure that from the driver position, I can't see the bottom of the ruler. That way it puts the comma right under your mirror. So I'm getting my son to hold it. I'm sitting back in my chair and just looking for that comma to be right under my mirror. He can hold it up against the straight edge and just kind of get a bird's eye of what the marker, we're gonna go 9 3/4. Got it pressed into place right around 9 3/4. That should put it right where I want. I'm gonna go outside and check the other side of it to make sure all the bubbles are pushed out. All right, looking at it, I got most of the bubbles out. I'll push on the edge a little bit. So here I've installed the solar shade. It basically keeps the sun off the top of the comma. There's a little reflection, so what I've done is I've put the reflection behind my mirror so that the comma is below the mirror, but the solar shade is, the reflection is above. It's only evident when the sun's at a certain angle, but want to certainly hide that or take it off while you're driving. This is my bank of 3D printers that I used for making the parts. I've been busy doing things for the hospital, but when it comes to creating optimal prints, you want to, of course, minimize your supports, make it easy to take it off, and have a few steps for cleanup as possible. So that's kind of where we got to. There still is a lot of work that goes into getting these things out to fit, but hopefully we're set up to make as many as needed. So the final step in making sure that you have a good product is to check that each and every one of them fit. I use aluminum tape to fix to the solar shield. It was actually a lot harder to get it to come out flat than I thought, but kind of we learned how. We're also using a big roll of VHB to hook to the back of the mount. I've tried to minimize it so that we have as little waste as possible. So what I do is I basically overlap it so that we have minimal waste between the two. And then I'm still working on the baffling that goes inside of these, but it consists of using some contact cement sprayed on the inside, and then we lay a piece of fabric or material in there. So to date we've made about a dozen of these, a dozen mounts, a dozen heat shields, and a dozen air scoops. So we'll have these available. I'm not sure the best way to do it, but we'll get those out, and hopefully we get some good results back. Of course, at this point, we can change anything. We can change anything to improve it. If people have other ideas, would love to see what you have. It was kind of expensive to do this project between the printers and the time on CAD and just all the prototypes. What you see here is probably 5th or 6th generation. So for everything that you see works, there's a lot of things that don't work. So we'll give this a shot and see what people think. So we've had a chance to test the heat shield and the cool air scoop in a couple different vehicles. Didn't have to modify anything. Right now I'm driving the mount in my vehicle just to see how it works in the sun. But one thing, whenever changing a mount, I always go under device and reset that camera calibration. I've seen that modifying the camera position even a degree or two does affect how the comma drives. And I personally like my vehicle driving down the center, and that seems to do the trick. Hey, good luck everyone. Thanks for watching.